Hey, how's it going everyone? Today I'm working on a convection Blodgett oven that is not heating. So let's fire up and let's see what's going on. So I'm going to start by putting it on cook high. And we do have a call for heat from our board. So let's go ahead, rip some panels off. And let's see what's going on inside this burner compartment underneath the cavity. Alright, so I finally got all the panels off. So let's go fire up one more time and let's see what's going on in this burner compartment. Alright, so we have our pilot, our spark turned off, which tells us we have flame sense. But our main burner is not firing at the moment. So let's go pull up some schematics and see what's going on. Alright, so let's just start out by mapping out our kind of roadmap here and sequence of operations. So we're coming right off the plug here, coming right down to our cook switch is where we saw our cook high, cook low. We're going to come through that switch, feed our cooling fan, but we're going to feed this transformer. So that's kind of where we're looking. And let's just map out our neutral. So we're going to come off this switch again. We're going to come right down. And we're going to feed our transformers. So out of this transformer, we're going to go 120 volts in, step down, 24 volts out. We're going to feed our module here on pins 2 and pin 6. And let's just map out our neutral side, or in this case, our other side of our 24 volts, which is going to be feeding our ground side for our module. And it's just going to branch into our main valve, pilot valve. From there, as soon as we get power to our module, we're going to jump into pin 1, which is going to get our pilot valve, is going to get its 24 volts. Okay, so our pilot will start going. Once our pilot starts going, we're going to get spark as well. Okay, once we get flame rectification, which we saw earlier, our spark will stop. So that's always a good hint. If you find that it's sparking for a really long time and then it kind of shuts off and the pilot's holding, it's telling you have bad flame sense. So either a bad flame sensor or a bad module. In this case, we have neither. All right, once we prove our flame and our pilot's lit, pin 3 is going to send power up to our centrifugal switch right here. Okay, so this switch will only close if this blower motor's running. And that's going to power our J11 pin on our relay. And then once we have a call for heat, it'll jump her to pin 9. How we get a call for heat is going to be off this RTD probe here. It's going to send a signal, hey, we're not at temperature, let's get a call for heat. And then now this J9 is going to send power down to our main valve. And that is basically our sequence there. So let's clean this up really quickly. So where we're going to start is we're going to see if we have power at this transformer. Okay, that's going to tell me if this switch is good. But I'm actually going to go right to the module here. I'm just going to go pick off pins 2 and pins 5. So let's go see if we have power on this module on pins 2 and 5. Alright, so I have my meter set up on pins 2 and 5 of the module. Let's go ahead and fire this guy up and see what happens. And helps if my meter's on. And we're getting 26 volts. Alright, so as you can see there, we had 24 volts on pins 2 and 6, which is telling us our transformer's good. Sorry, pins 2 and 5. Let's just draw our neutral down really quickly here. We won't go all the way back to the plug. You guys get the idea. So that's telling me we have power right here. Okay, so now we got to think, what's the load that's in question? It's definitely this main valve. So there's two ways to troubleshoot. I can go point to point from pin 3 and chase it through this way. Or I can go from the load, which is where I usually start troubleshooting. And we go from here and start working backwards and see where we're losing the flow of electricity. So I'm going to go check for power at this main valve and go from there. All right, so let's go fire up one more time. Let's get our meter set up on our main valve, which we're set up right here. And as you can see, we're on MV, and we're getting no voltage at the gas valve. Alright, so we have no power at the gas valve here on this terminal. So all we're going to do now is I'm going to go on pin 9, see if we have power there. And then I'm going to go test pin 11 and come back to the schematic. Alright, so we're going to start with pin 9 as we said. We just have a normally open relay here, and this relay just closes its contacts whenever we get a call for heat. So we're in there with our alligator clips. Make sure you're using your alligator clips for this. It's easy to short those two terminals out. And let's fire up here. And let's see if we have power coming out of this relay. Like I said, we're working backwards. And we do not have power out of the relay. So next thing, let's check if we have power into the relay, which is our J11 connection. And we do not have power there either. Alright, so as you can see there, no power on J9, no power on J11. Okay, so J11 is connected to this centrifugal switch. So I'm going to go check for power in this centrifugal switch. If I have power in and no power on coming out or on J11, that's telling me this centrifugal switch is not closing. So let's go test this switch right now. Alright, so we're hooked up here into the centrifugal switch, power in. Let's go fire up and let's see if we have power here. And we'll wait for our flame sense. And we have 25 volts into the switch. Alright, so we have 25 volts coming into our switch, and because we have no power coming out, that tells us this switch is open. So pin 3 is definitely sending power. You know that because we got 25 in. We have no power out. So this centrifugal switch is open. So what closes this switch? As we said earlier, this blower motor right here. So let's go investigate this blower motor and see what's going on. Alright, so let's go ahead and test this motor really quickly. So let's fire up. We'll start off on the high speed here. I'm just going to bump the door switch. Be really gentle with this door switch. I'm just doing this to show a visual, just so you can see whether the motor's running or not. And as you can see, the motor is clearly not running. So what we're going to do next now is let's go down to our low speed. And let's bump the switch one more time, ever so gently. And same thing, no action here. Alright, so next thing to do is let's verify we have power going to the motor. Alright. So we're going to start with our low speed here. And we do in fact have 117 volts. That's good. Okay, let's kick over to our high speed. And let's see what kind of voltage we are getting here on the high speed. And on the high speed, 115 volts. That is good. Alright, so based on that, we have our high speed, low speed, whatever you're choosing here. So in this case, let's just come off this this pin 6. So power's completed there on that circuit. And then power's going to come up through here. And depending on high speed, low speed, it is going to send power. But if we look right here, we have a capacitor. Okay. So potentially this capacitor is bad. So let's go test this capacitor before we condemn this motor right here. Alright, so let's go ahead and test our capacitor. So obviously power off, pull off one of the leads, ground out your capacitor. And we're getting 1.772 microfarads. So let's go ahead and pull out this capacitor. Let's see what the rating is on it. I can't really see in there. Let's just cut this tie wrap off really quickly and pull the cap out, and let's see if we're within our range or not. And generally we're allowed within 10% of the reading on the capacitor. So as you can see here, we have 10 microfarads. So that's telling us this capacitor is bad. Alright, so because I work on these ovens pretty frequently, I know the visual cues. So one of the obvious visual cues is if this motor here is not running, I know this switch isn't closing. If this switch isn't closing, we're not going to get any heat. Okay, so in this instance, I did test 1, 2, 2 extra components, whatever. It took me an extra minute just to show the flow of electricity. But when you really understand the schematics and you understand the sequence of operations, you start looking for visual cues. So I know on these convection ovens, when I have a call for heat, my blower motor has to be on. So our motor might still be potentially bad because obviously, you know, you can burn out the windings and stuff like that. So let's just see if we can kickstart this motor. And it kickstarted really easily, so that's telling me the motor's probably still in good condition. So let's go ahead and go grab a capacitor and pop it in and see what happens. All right, so we got our capacitor here. Let's just go pop this in super quickly. And as noted earlier, you know, make sure you're grounding out your capacitors, power off, all that good stuff. All right, capacitor's in place. She's strapped in. And let's fire up and see what happens. So we're good there. We have our flame sense. And our main burner has fired up. And as you can see from that, our blower motor is running. So my goal now obviously is to test it in low speed. So I want this blower wheel to come to a complete stop. Okay, I don't want it started in low speed and it's already moving, because that's like the equivalent of me starting with that screwdriver like I did earlier. So we want to make sure it's running on both speeds, because I've seen it where it only works on one speed, so some of the windings are bad on either the high speed or low speed. So let's get our complete stop here. Let's toggle down to low speed. And let's fire up one last time. And our burner has turned on, and as you can see, our blower wheel is running. Because it's a convection oven, only runs in one direction. So we're all good here. We did not need a motor. It was just a bad capacitor. It's important to look for these visual cues. Why they're important is it saves you tons of time for troubleshooting. Okay, in this case, like I said, it took an extra minute to show testing these extra contact points. But when you're working on bigger schematics or bigger units or more complicated stuff, the visual cues really help you to map out your diagram of where you're going on the map. Okay, because it tells you, hey, I don't need to test this component because it's running. I can go to the next component or the next thing in line in that sequence. So it's really important that you're looking for your visual cues. So on these Blodgett ovens and most convection ovens, make sure your convection blower motor is running. That's a big cue as to why you may not be heating.